In this video, we'll talk about glue for string injection. So what's glue? Glue is a simple, lightweight package that is used with one purpose in mind, and that is to create strings. And it does this via a process called string injection or string interpolation. Other languages have actually native support for this. So Python has a concept called f-strings, Julia has just its regular strings, and Bash has strings as well in that kind of weird way that Bash does. And to understand how string interpolation works, we first really need to know how to create new strings by combining other strings, okay? In Python, again, these are built in with the plus operator, Julia times, and Bash just does it just by putting quotes together. R concatenates things with paste and paste zero. So let's see how these work. These are both base functions, and they're used to concatenate strings together. So paste A, B, of course, those are individual strings or character vectors of length 1, will return a character vector of length 1. So 2 characters in, 1 comes back, and this is the sense in which it's kind of playing the role of plus, almost in an arithmetic sense, but things are kind of as simple as they seem here. So 2 in, 1 out. Now this function has to be variadic because it doesn't know how many are going to come at you at the beginning. So you can do paste A, B, C, and you get 1 back. So A plus B plus C is A, B, C, just like that. You can change the separating character. Notice here that before, I didn't mention it, but there are spaces. That's the default of paste. And in fact, that's what differentiates paste from paste zero, as we'll see in just a minute. If we wanted to change that separating mark, we could use the sep argument of the paste function. And in fact, you could use sep with this. I haven't mentioned this before either. This is called the empty string. It is a character vector of length 1. It just so happens to not have any characters in it. So again, if you think of a string as an array of characters, and you remember that you can have arrays of length 0, that's kind of like what this highlighted thing is, this empty string. It is a character vector of length 1. It just so happens that the string that is contained in that length 1 itself has 0 characters in it. Okay, and that functions to kind of smash all of those characters together. And in fact, that is precisely what paste 0 does. So paste 0 is simply the paste function, but it defaults to having sep not equal to the single space, but to having no space whatsoever, to having no characters, okay, the empty string. So this is literally going to slam all of the elements together. Now, paste and paste 0 both are also going to accept not just character vectors of length 1, but its arguments can be vectors in general. So here we see I'm passing in the character vector of length 1, that is x, and then a different length vector 1 to 3. And the result, this is paste 0, right, is x1, x2, x3. If this looks familiar to you, that's because this is very often used in R to create names of data frames when they're not there, or a construct very, very similar to this. Now, paste can also perform a different task. So when it would pass back a vector, notice of course in this paste 0, there was a vector in and there's a vector out. If you want the vector out actually to be of length 1, you can use the collapse argument. So what it's going to do is it's going to take those elements and it's going to then force those elements into being kind of like the input of paste over here. So the result is going to be of length 1. It's going to smash everything together. Now, what is the separating character going to be in that case? Well, that's the one that's called collapse, not sep, and it's going to literally just push those strings together and use the mark here, however long it is, as the separating character or sequence of characters, as in this case. Okay? Now, you can actually use these things simultaneously. So sep, again, is going to be the characters that separate the individual arguments that are passed into paste, and then collapse is going to be the separating characters that separates the elements of the would have been output vector into 1. Okay, so here we have first names, last names, George, Thomas, Washington, Jefferson, and the result is George, Washington, Thomas, Jefferson. The sep is the space, and the collapse is the comma space. Okay, great. Now, there's another function, not called sprintr, it's called sprintf, or probably the better way to say this is sprintf, okay? And that is because it's coming from something lower level, it's coming from the printf command, okay? This is going to be our first example of something called string injection. It's going to do something similar to paste, but in a slightly different way. First, I'll remind you of how printf works. Printf is going to take the contents of a variable. So here, name is David. This is a shell script, right? Echo, double quote, so that's the one that allows string injection. Dear $David. So what's happening here is $name, not $David, excuse me, is going to be replaced by David, and that's going to be injected or interpolated into the string. Okay, and the result is Dear David. Now, if we used printf for this purpose, so this is like kind of how shell would do things normally, and there's nothing wrong with this. This is how you would normally do it. However, shell script also has this printf command, so print formatted, and in that case, what you do is use printf, you give it the string that you want to have the ultimate variable value injected into. So here the variable value is the string David. But the way that you do it is you actually put a placeholder in the string. In this case, it's %s. And then that %s is going to be replaced by the value that is passed as the second argument to the printf command. And again, you get the exact same thing, Dear David. So this is a little nicer because you can actually write out the whole string that you want, and you're just kind of like leaving little breadcrumbs in here. Hey, inject the value of the next thing at this point, okay? And that is exactly what sprintf, not sprintr, does. So if we go back to R, we can see this working. So I'm going to make two variables, first name and last name, David Kale. And if I do paste 0, dear, comma, first name, comma, so notice that I'm kind of trying to create that salutation, right? A dear space David, so on. Notice, by the way, that I'm having to put this space here because I'm using paste 0. If I had not put the space there, of course that would run together. Well, I could use paste, the regular paste, not paste 0, but if I had done that, then there would be a space kind of right here between the D and the comma. So this is always kind of a tricky thing because punctuation doesn't have spaces between it and the preceding character or non-space character, right? So you have to kind of construct things in this weird way, and you'll end up having to put these spaces in these strange places. String injection really makes this a lot easier. So I can use the sprintf function. I say dear space %s, again, there's that placeholder, and then first name is going to be the expression that is evaluated, and then its resulting value is injected into the original string. So it works just like up here, just like at the Linux command line, and that's because it was modeled after it, right? So sprintf, S being the language that preceded R. Now, if you wanted to do this, you may say, well, this is kind of like a minor thing. In bigger situations where you have larger templates of strings that you're trying to construct, paste really becomes unwieldy. So here's an example where I want to say Dear David Kale. Well, now I have to be really careful with the spaces. So here's a space here, first name, now we need another space, last name, and you kind of see just symbols all on this line. That's usually what happens when you're trying to use paste to construct something that is complicated and it's like a sentence, okay? So paste is almost never used for that purpose. Something like sprintf, or as we will see, glue, is going to be used for that purpose, okay? Now, how would sprintf do this? It would do it just like this. Here's the template of the string that you want to create, and then this first argument is going to go into this %s, this argument is going to go into this %s. Now, this function is actually very flexible, so I'm only scratching the surface here. The s can change to different things depending on what type of a thing is it. Is it an integer or a floating point number or what? And then sometimes you'll want to reference the same string again. So you can imagine if you're writing a whole paragraph, you may refer to the first name at the very beginning, but then the first name is going to go in other places as well. You actually don't need to repeat the argument first name over and over and over again. There is kind of like a little language of these little percentages that you can read about in sprintf where you can refer back to previous ones. But we're not going to be interested in that anymore because we're going to glue. Glue is like sprintf, but it's going to use special delimiters so that you don't have to have several arguments of the function. There's only going to be one, okay? Now, what is that one? The one, meaning, like, how does this work? You're going to have one string that's passed in. That's it. One argument, and it's one string. But that string is inside of it going to have special demarcations that tell R, oh, this part is actually code that needs to be evaluated and then put in this spot, okay? Now to do that, it's going to use the curly braces. So the curly braces are not going to play the ordinary role of their curly braces in a string. They're going to play a special role, okay? Let's see this work. So same first name, last name, same sprintf command from before, okay? Here is how glue is going to do this. dear, and then here come these demarcation, right? First name. So anything between the demarcations is going to be considered to be our code. That our code is going to be pulled out, evaluated on its own, and the result is going to be then injected into the original string, and it will also clobber the curly braces entirely. So we get Dear David Kale. The first name is being injected and the last name is being injected in a nice, clean way. So this is really what glue gets you. Here is the sprintf command, which was already a lot better than paste or paste 0. And then here is glue, which makes it very, very clear what's going on. Okay, so this is string injection or string interpolation. You can see that it's actually doing the evaluation of the expression by doing something like this. I'm going to define a variable 1. Its value is going to be numeric 1, right? And now I'm going to create one string. Let's look at the string. So it has two things that are going to be injected. The value of ONE, well, that's 1, right? So 1 and then plus 2, that's actually part of the string. So that's not a arithmetic thing, right? Equals, and now let's look here. This is really where the expression is that's going to be evaluated. ONE plus 2, when that's evaluated as our code, it's evaluated to 1 plus 2 is 3. Now that 3 is going to get pulled out and then injected so that we get 1 plus 2 is 3. Okay, so this is how glue works, and if you understand this, you kind of understand all the basics of glue. Okay, now there are a few other perks that you get from glue that I should mention, but they're really not that big. One is that the output of glue is actually a character vector, but it's a special S3 class character vector called glue. So it is of class glue first and then character. The character is going to mean that the output of glue is just like the output from sprintf. The only difference is it's also of preceding class glue, and that's going to allow you to essentially just define some methods that make things a little bit easier. Okay, let's look at how some of this works. First, the formals of glue. I said before that there are special demarcators that signal to glue, hey, here our expression is beginning and here it's ending. Okay, depending on the context, you may actually not want those to be curly braces. You may want it to be hard braces or something else. Okay, in those cases, you can just change the dot open and dot close formal arguments. Okay, so you may make them hard braces or you may make them something else. Okay. You can comment things with comment, although I have not gotten this to work and I suspect it's actually broken. Okay. In any event, here's an example where you may want to use hard braces for glue. Let's say that you were actually going to write code that converted kind of a basic type of LaTeX into a character vector that actually contains real LaTeX. Okay, so you can imagine, for example, that you're trying to make some code that says begin a certain kind of environment and end a certain kind of environment, but the kind of environment could change. It could be an itemized environment, an enumerated environment, it could be something totally different. Okay, so here I say environment type is enumerate, and then here comes the string that I'm injecting into. Don't worry about the double backslash right now. Now, the curly brace in LaTeX has a special significance, so we don't actually want to remove that, right? We don't want that to be what starts the glue's triggering as like, oh, I need to evaluate this expression and then inject it in. We want to use something else. So what we'll do is we'll put env type, this variable that we made right here, in between hard braces instead of curly braces, and then we'll just tell it, hey, the opening character is a hard brace, the closing character is a closing hard brace, and now it is returning begin enumerate, which is proper LaTeX code, and it doesn't actually clobber those curly braces. Okay, great. Other little glue perks that come from the fact that it's not just a character vector, that it's a glue object. Whereas plus does not normally work between character vectors, as we're aware in R, it does work between glue things. So this is very kind of Pythonic in a sense, where it feels like you're in a different language, where now you can just use the plus symbol between strings and it actually just concatenates them together, just like paste 0 would. Okay. Now there are other little perks as well. If you put a line break, which is if you're inside of a string and you just push enter, all that does is it actually enters a special character into the string that you're writing, and the special character goes by the kind of name of /n. So that /n there is a new line character. Okay, if this is the first time you've encountered this, it's a little weird, and I'll have to elaborate on it a little bit later. But that every time you're doing a line break, that's a /n character. Now, it can be kind of awkward if you're trying to input one long string, but you don't want the ends in there. Okay, you don't want the slash ends kind of like interspersed in what you're doing. You just want to be able to see the string kind of vertically without like going horizontal and like having to scroll over to see it. So to do that, Glue provides this. I should say at the outset, if you put the line breaks in there, Glue is going to put the line breaks out in there too. But if you use double backslash here, it's actually going to recognize, oh, the user is just flowing that one string, not with the line breaks in it. It's just a long string horizontally, so it doesn't want to run it. He wants to run it over lines so he can see it all at once. So that's a nice little perk with Glue. Okay, that is the rest of Glue, and so let's move on into Stringer.